Hey everyone, welcome back to Learn with Pooja. The course is RAG, Retrieval Augmented Generation, Part 2, Foundation Models. Today we are going to discuss about foundation models. Foundation models, including large language models and multimodal models, are the core building blocks of modern retrieval augmented generation systems. These models are used in two key stages of the RAG workflow. One is content preparation, which is ingestion, and another one is answer generation, that is a query time. Foundation models in generation page. During the generation step, language models is like a ready the retrieved context, analyze the user's questions, generate a response that is grounded in the retrieved information. This ensures that answers are based on relevant sources material rather than guesses or unsupported assumptions. Foundation models in the ingestion page. Before data can be retrieved, it must be processed and prepared. Multimodal foundation models help by extracting text from images, which is OCR, and transcripting audio into the text, summarizing long or complex documents, adding metadata that improves such and retrieval quality. These steps transform raw content into the format that can be effectively indexed and retrieved later. What this chapter covers first, this chapter focuses on the foundation models used in both pages of RAG system, ingestion page and generation page. Ingestion page where content is processed, transformed and prepared for storage. Generation page where retrieved information is analyzed and used to generate answers for users. Understanding how these models operate in each phase is essential for designing reliable, scalable, and accurate rack systems. Examples like use a vision model to analyze video frames, use speech to text and embed the resulting text using an embedding model. Retrieve relevant context when you just ask questions. Generate answers using a large model. You can see in this picture, this is a race recording and moderator car. So it's going to the two models. It contains like a vision model and speech model. It converts into the text and convert into the embeddings. Embedding is storing into the vector store. From the vector store, we are sending the context into the LLM. LLM is generating the response based on the user query. So this is the workflow of RAG system. Every RAG system needs a generation model that interprets the retrieved content and generate the required output. Whether that answer a user question, producing a report, or completing another specific task, the following recipe shows how to design effective prompts, choose appropriate models, and generate structured outputs. Defining a suitable prompt template. You need to define an effective prompt template for the generation step of the RAG application. For RAG application, prompt follows a structure pattern. A suitable prompt template consists of the four key components. First of all, one is a role that defines how the assistant should behave, an instruction that describes the task. The third one is that the retrieved context the model must rely on. And the fourth one, output requirements that define how the answer should look. This structure guides the model towards grounded responses by explicitly instructing the model to use only the retrieved context. User can later review the sources and verify that the answer is based on real information rather than hallucination facts. You can see the prompt how defining in this image. The role and instructions are task and context input or output or expectation. The role, for example, influences tone and technical language. Instructions or task, what should the model do? Context is like a relevant documentation, facts. These are like coming from the rack context. So output or expectation is like a format, style, length, and matrices. These are like a main four components in the prompt engineering. So prompt templates in rack systems, there must be as we discussed, a prompt template create a consistent structure that constrains model behavior and reduce unpredictable outputs. Each part of a well designed template serve a specific purpose. As I mentioned, a role is a set expectations for the model, expertise level, and communication style. Instructions are defined success criteria explicitly instead of relying on implicit model assumptions. Context is the grounds the model in retrieved facts and limits reliable reliance on internal training data. Output requirements enforce formatting rules to prevent errors that can break downstream processing. Balancing flexibility and control. Effective prompt templates strike a balance between guidance and freedom. If templates are too loose, so the model may inject irrelevant training data. Citations or facts may be fabricated. If templates are too strict, the model may refuse to answer valid edge cases and partial but useful information may be ignored. The best templates are redefined through testing with the real user queries and adjusted based on the observed failure pattern. When to use prompt templates? This is the main important, like I use structured prompt templates when downstream systems needs to parse the model output. The second one is a consistency and reliability matters more than a creativity. The application is production facing or automated. When should avoid this? Supporting exploratory and conversational interactions, open ended reasoning is more valuable than strict structure. Practical considerations is like a prompt template increases token uses. This is the main important in LLM. And every retrieval and generation call pays this cost. So template should be cosine, purpose driven, no more complex than necessary. Well designed templates improve accuracy and reliability without sacrificing efficiency. Selecting the right language model for your task. How to select it? Choose a generation model for a rack system. A retrieval augmented generation system depends heavily on the generation model you choose. If the model is too weak, it may misinterpret retrieved context, produce incomplete or unreliable answers. If the model is too powerful, it may increase response latency, significantly rise operational cost. The goal is to select a model that provides sufficient reasoning and accuracy without unnecessary expense. The solution for this, all major AI providers offer families of large models in multiple types. These types range from high efficiency models for simple tasks to advanced reasoning model for demanding workload. Each type represents a trade off between accuracy, reasoning ability, latency, and cost. So, summarizes what each type is best suited for, where it struggles, and which model typically belongs to that type. Large models, large language model selection framework. It's like you have to consider these following steps. Ultra efficiency. Ultra efficient is like a simple task and lightweight workload. high throughput, real time response, classification, and quick question and answering, and edge and embedded use cases. These are like a typical use cases. Like you can, we have like some example models: Gemini 3 Flash, CLAD, and GPT-5 Nano. These we can use for ultra efficient models, efficient and everyday. So then general productivity task, text generation and summarization, chatbots and support assistants. So these are like everyday we can use for these models, like a Gemini 2.5 Flash, GPT-5 Mini or GPT-4 one. So recently which are came. So and flagship, complex and creative tasks, deep analysis and structured reasoning, avoid code generation, customer facing automations. These are like a Gemini 3 Pro or GPT-5, CLAD, Sonato 4.5. So, like these are the flagship tier, and reasoning and frontier. For reasoning and frontier, multi-step logical reasoning, scientific and mathematical task, long context planning and proof, automation or agentic workflows. For this, we can go for GPT-5 or CLAD or POS 4.5. Like these are the different. These are the reasoning and frontier models. Like we have a lot of models in open source, we can utilize for that based on the our required category. And now cost considerations, this is main important for real time. So cost plays a major role when deploying rack system at scale. Commercially, providers such as LLM charge separately for input tokens and output tokens. Input tokens processed in parallel during a single forward pass. Output tokens are more expensive because each token is generated sequentially while conditioning on all previous tokens. So, as a result, long or verbose answers can dominate total cost. How to choose in practice. When comparing models, compare within the same type, not